Hello class, this is Building Construction for the Fire Service, Chapter 8, Heavy Timber and Mill Construction. This chapter provides an overview of heavy timber and mill construction, focusing on their characteristics, specific fire hazards, and concerns for demolition and renovation of these structures. The objectives we're going to cover in this chapter are: we will identify and describe the characteristics of heavy timber buildings and specific characteristics of mill construction, which is type 4 construction, and identify the dimensions of heavy timber members. We will describe why the misnomer slow burning is inappropriate for heavy timber buildings. Also, we will identify the specific hazards of these conflagration breeders and identify specific problems with mill construction. Also, we will identify the dangers of concealed spaces in renovated mill buildings and identify the differences between new heavy timber buildings and those built in the past, and describe the hazards of vacant heavy timber buildings and structures that are under demolition. So let's talk about the history of mill and heavy timber construction, some of the definitions and origins. Heavy timber is building construction with a non-combustible or limited combustible exterior wall and floor made of large dimension combustible materials, also known as type 4 construction. The first origins are in medieval England, and they were also constructed in early American settlements when America was part of the British Empire. Later it moved to post and beam construction. Barns and churches used large wooden members, and churches incorporated masonry walls. Some examples are on the left. You see the Slater Mill in Pawtucket, Rhode Island, which was built in 1793. On the right, you see a reinforced concrete factory mimicking the look of heavy timber. With mill construction, you have exterior bearing and non-bearing walls that are solid masonry. Columns and beams are of heavy timber with cast iron connectors used to cover joints where fire might obtain a hold. The chambered columns have beveled corners for exactly the same reason. Floors are of thick grooved, splined, or laminated planks. Roofs of thick, splined, or laminated planks are supported by beams or timber arches and trusses. The openings between floors are enclosed by adequate fire barriers. The ends of girders are fire cut to release in the event of collapse without bringing the wall down. Sometimes a cast iron box is built into the wall to receive the end of the girder, and sometimes the beams are set on a corbelled shelf. That's an example of what you see below. Scuppers in the wall will drain off water, reducing water damage on lower floors, and concealed spaces are eliminated. A large number of windows are used to provide maximum lighting to the interior of the mill, which is this type of construction that we're talking about that you see below. One-story sawtooth mills featured a set of windows at the vertical portion of each quote-unquote tooth. The protection of vertical openings and the division of the building into sections by firewalls are vital in this type of construction. An automatic sprinkler system with a water flow alarm and an alarm connection to the fire department is crucial. Special hazards should be located in detached buildings. Fires can be brought under control before the building is involved in the fire. Slow burning characteristics are of no value when the fire department must fall back to defensive tactics. Slow burning, that is a myth. Proponents of heavy timber construction believe that slow burning means collapse resistance. They certainly are not the same. This statement is true only if the fire department can maintain interior offensive operations. That depends on how quickly the fire department gets there, basically. So let's talk about the definition of a conflagration breeder. This is a structure that presents severe exposure problems that are capable of initiating a conflagration, which is a large multiple building fire that is not easily contained. The characteristics of a conflagration breeder mean that there are a tremendous amount of radiant heat from each flaming window opening. The production of numerous large firebrands, such as large collapse zones for tall walls, fire can spread to wood frame homes, shut-off sprinkler and standpipe systems, open equipment shafts, and large uncompartmented areas may or may not exist. Improperly maintained fire doors and lack of compartmentation is a frequent problem, and sometimes you have sealed up window openings, and stair shafts may be an area of refuge for firefighters depending on how they're made and how they are protected from fire, like with cement block or something like that. When fighting a conflagration breeder, make sure you expect the fight of your life. You will need a large water supply, numerous heavy caliber streams, a large collapse zone, an extensive brand patrol downwind, and frankly, a lot of luck. Now let's talk about remodeling. Renovation often detracts from the original fire characteristics. Columns may have been replaced. New trusses do not have the inherent resistance of old columns and beams. So these are all things you should watch out for in renovated old buildings. And then changes in use. Conversions to tenant factories, school storage, discount stores, and apartments mean that there have been many internal changes. Fire loads are often beyond the capacity of any installed sprinklers, and unsprinkled areas are invariably created when buildings are subdivided for new use. Then you have heavy timber building. This requires careful maintenance. Metal connectors may provide a heat path. Only a full sprinkler protection can prevent disaster. Take note of renovations and conversion to new use. So in earlier chapters when I talked about getting to know your fire area, fire response area, this is a really good example of why that's so important. You sure as heck need to know what that building is like now versus once it's fully involved in a fire. With heavy timber building, concealed spaces may be created during renovation, so deficiencies should be clearly noted when inspections are done, and realistic pre-fire scenarios are required. In other words, anticipate what's likely to happen in this building during renovation when there's a good chance of a spark or something like that causing fire, and even after the building is constructed or finished being renovated. You need to know where potential problems will lie. Now let's talk about some more about heavy timber construction. New buildings made of heavy timber construction. These are classified as type 4 construction, and they probably lack at least one feature vital for fire safety. Some typical deficiencies include cast iron or unprotected steel columns, steel or part steel trusses, unsprinklered void spaces, highly combustible contents, unprotected vertical openings, and inadequate or no sprinkler protection. Wow, that's a lot to face as a firefighter. So again, know your fire response area. Continuing with heavy timber structure, they're not built as commonly as in the past, and there is a niche for certain types of occupancies. The most common use is the modern heavy timber church. Here are some examples of heavy timber structures. On the left, you see a laminated wood truss in a modern church. On the right, you see large glue laminated timbers that are used to form roofs and walls of this hockey arena. Here's a table 8.1 in your book. You definitely need to read this. It has a lot of very important information, certainly more detailed information than is in this recorded lecture. But this is in your book, and you absolutely need to read this table and become very familiar with it so you know what to expect when you're out trying to fight a fire that's made out of this kind of construction. And again, get to know your response area and adjoining response area if you're called in on mutual aid, so you're prepared to encounter a fire in this type of construction. Now let's talk about heavy timber construction contractors. Be wary of those who claim to be erecting a heavy timber structure. Many do not know the actual dimensions that are required, unfortunately. Heavy timber theory means that heavy timbers are difficult to ignite and will char on the surface only. Yet, floors of most heavy timber structures are often soaked with a variety of flammable and combustible fluids over the years, altering ignition and combustion characteristics of the floor planks and beams. So they may initially have been somewhat fire retardant to a degree, or slow burning or slow to ignite, but over the years people have lacquered floors or painted the inside with protective coatings or epoxies. That completely changes the chemistry and the capacity for fire. Now let's talk about vacant buildings. Cities with recent massive downtown fires that include vacant buildings are Baltimore, Philadelphia, Lynn, Massachusetts, which is just north of Boston, Minneapolis, Indianapolis, and Montreal. All of these are fires that you can look up online and you need to study. Characteristics of massive downtown fires. Old combustible interior masonry buildings that were being remodeled, and sometimes these are buildings that were usually wide open where fire barriers were removed or inoperable. Sprinkler systems had been removed or disabled, and the only fuel was the timber interior structure of the building. Also with vacant structures, you have sprinklers that are turned off, and unfortunately and sadly, vacant structures can be an invitation to arson. With sprinkler systems, full automatic sprinkler protection is necessary. Even yard hydrants may be turned off, and so pre-planning for this type of renovation is critical, and the inspection process and ongoing inspection process during renovation is also critical. Okay, let's summarize some of the things we went over in this chapter. First, historically, heavy timber construction, including mill construction, has been used for large structures that have been uniquely vulnerable to fire. Many of these sturdy old buildings have been around for a very long time, and often efforts made to remodel them have detracted from their original fire characteristics. For example, steel trusses or girders may have been inserted, making it possible to remove some columns. The new trusses, by their nature, do not have the inherent resistance of the massive wooden columns and beams that they replaced. Today, heavy timber construction is classified as Type 4 construction. Proponents of heavy timber construction often advance the term slow burning as an unqualified advantage because of collapse resistance, when in fact the slow burning characteristic is an advantage only as long as the fire department can maintain interior offensive operations, provided they get there quickly enough. Once the fire department must operate defensively, slow burning delays extinguishment and prolonged air pollution can occur. A building conforming to the code definition of heavy timber construction probably lacks at least two or more of the features of the mill construction designers had learned were vital for fire safety. Of particular note are ceilings placed directly under beams, creating dangerous concealed spaces for fire spread. Full sprinkler protection adequately maintained is the only fire protection measure that can reasonably expect to prevent a disaster in heavy timber building. We also discussed how problems arise when buildings are abandoned, are converted into multiple unit occupancy, or are prepared for rehabilitation into apartment or office occupancies. The fire department should anticipate these problems and plan accordingly. Today, heavy timber structures are not being built in record numbers, but they still find a niche for certain types of occupancies such as churches and synagogues. Sprinkler protection is often turned off in vacant buildings made of heavy timber construction. Okay, class, that's it for this chapter. I would always encourage you to make sure to contact your instructor if you have any questions about anything. And there are several specifics we went over in this chapter that you need to read about in your text, particularly the table that I showed you that outlines different types of heavy timber construction. So I encourage you to make sure to read that. As always, thank you for your time and attention. We'll see you next class.